Hi, I'm Andrew Harvie, technical writer here at Trihedral Engineering. This is the first video in a series that will explore the VTScada login and reporting features. Now, before I begin, let's take a moment just to review what goes into making up a report. Now, first, there's information. You can't create a report unless you've saved some information to report on. So in this first video, I'm going to take a look at the VTScada Historian and show you the configuration of that. The second basic part is calculation. Very few reports are simply tables of raw values. So let's take a look in the second video at various tools that are available to help you create calculations. I'll show you how to collect information, the totalizer tag, the counter tag, the history statistics tag, and also the calculation tag. Now that one allows you to monitor several other tag values, and you can access the VTScada's function library in order to do whatever math you need on the result. The final part of reporting is presentation. VTScada gives you two tools for that. There's the Historical Data Viewer, or HDV. There's also the Reports page. So in the third and fourth videos in this series, we'll take a look at each of those in turn, and I'll show you tags, widgets, configuration options to control how they work and the presentation of the information. Now, VTScada's reports, they do tend to be somewhat plain. So in the final video of the series, I'll show you how you can reach into VTScada's database, pull out the information, and then you can use it in some third-party program that allows you to have whatever fancy formatting you'd like to use. Now, two things in particular that I'll focus on. There's the ability to export your raw information to a macro-enabled Excel template. Now that can automatically for you take the raw information and format it and do whatever calculation you need. You can also configure VTScada so that a third-party program can reach in and using SQL queries pull out whatever information you need for the report. So with that as the plan, let's begin by taking a look at the configuration of the VTScada Historian. For this video series, I'm using the completed tutorial application. Now it's been modified with a few calculation tags that are going to watch the tank levels, start in and stop in pumps, and open and closing valves automatically. The point is that that's going to give me some numbers that I can use to demonstrate logging and reporting. Historian configuration is done using a tag. Opening the tag browser, I'm going to find that every single VTScada application will have a System Historian tag. Now, for most applications, this is the only historian tag that you'll ever need. Opening the properties of that tag, we can see its basic configuration. Now, the name cannot be changed, but you could change the area and the description if you found a reason to do so. Opening the Data Store tab, I can see options here for how and where information is stored. Now, be careful. This configuration must be done before you commission the application and start collecting data. Once the application is up and running and you have information stored, you cannot change the storage type or location without losing access to what was saved before this change. So very, very important. Plan your application at the beginning and make sure you've got your configuration done here before you start actually collecting information. Now with that in mind, let's take a look at the options. First, I've got a choice of representing system downtime as missing data. Now certainly, while the system is down, nothing's going to be collected. What this choice controls is that when the system comes back, and I'm creating a report later on, will that missing information be shown as a gap in the record, or will it be shown as a flat line from the last recorded value until new values come back in? The storage name, type, and location have default values that they're not even shown, but the name allows me to change how this is going to be stored if I'm using an ODBC format. So by default, if I store to a database, a third-party database format using the ODBC connection, the historian tag's unique identifier will be used as the identifier for where this is coming from. Now, that's a very, very big identifier, and therefore most database programs will truncate it. The result might not work, or if you have two historians, the truncated result might not be unique. Therefore, if you're storing using ODBC to a third-party database, you have the option here to create a unique name to use instead of the guaranteed unique identifier of this tag. The type is a choice between two keywords, either file, which is the default, or ODBC. If you're storing to the file, that means you're storing to the VTScada's database storage format. So I could type the word file here, but it is the default and therefore not necessary. If I want to store to a third-party database, I would type the letters ODBC to use the ODBC format, and that will tell it to use the different storage mechanism. Finally, the storage location controls where the information will go. If I'm using the default of file, the storage location will be the data folder underneath the application's overall folder within the computer. Now, you can change that if you want to. You could put in the name of any folder on your computer to use instead, or a folder on the network. Again, remember, don't change this after you've been collecting information. Make sure you plan your system ahead before you commission it and put it into use. Now, if you're using the ODBC storage type, then the storage location becomes the connection string in order to send information from VTScada to your third-party database. Now that could be either a DSN name in the format DSN equals whatever name you create using the Microsoft ODBC configuration tool, or it can be the full configuration string that identifies the type of database, the location, the username and password to connect to it. Okay, I'm going to leave the defaults in place and move on to the third tab, which is storage limiting. Now, you can, if you choose, throw information away. The default, naturally, is to keep everything. But if you have a reason to, you can choose to delete information after a certain length of time or a certain number of records for each tag. The sweep interval controls how often. This is controlled by a configuration variable that sets a percentage. Now, the default is that it sweeps rather than one record in and one record out. It goes by a quarter. So 5 quarters will go by before it sweeps out the last one and then continues collecting again. Or I could store a certain number of records to keep to whatever number I choose to put in there. Again, I'm in the point of view that nothing should ever be thrown away, so we'll leave that be. So before I close this, again, I'm choosing to keep the default configuration of using the VT data store. If you have a reason for using an ODBC format, well, go ahead and configure it. But rest assured, the VTScada data store has been designed to be rock solid, reliable, regardless of the size or complexity of your application. It will usually be the most dependable and most probably the fastest of your options. If you need to store to both formats, that's possible as well. If I've got my application running on 2 separate computers, so I've got a networked application with 2 servers configured, it will automatically keep a backup of information on both servers. If on one server I've configured my historian to log to the data store, the VTScada data store, and on the other to ODBC, I can save to both formats at the same time. Now, clicking on OK, closing that, if you want to monitor the health of all the historian tags in your system, you can do that by adding the historian status widget to any page. To do so, you open the Idea Studio, and then within the Analytics and then the Trends and Historical Data, there's an Historian Status widget that can be dragged and dropped onto any page. Now I'm going to obscure part of my display to put this in here. There's no configuration that needs to be done other than perhaps changing the width and size of this. Put in my application back into Operator View, in other words, close in the Idea Studio. I can see here's my system historian. The current server is my workstation. And I can see that I'm connected and I've got a queue length of 0. Now the queue length is worth keeping an eye on. It will normally fluctuate a little bit up and down, but if you see that it is steadily rising, well, then your storage system is not able to keep up with the values being collected. So what you need to do is to check what else might be interfering with access to your hard drive. The queue length will increase if the write rate, that's the number of records being added to the queue, is greater than the database storage rate. All right, that completes the first video. In the next one, I'll take a look at collecting information and then some of the tools that VTScada gives you for doing calculations before they're stored